Welcome to Spring LIB.
In this question, given data is there is a figure given. So first I will draw this figure. So in the figure it is saying that a block of mass 200 gram is suspended through a vertical spring, and this spring is due to 200 gram is stretched by 1 centimeter. That means it will stretched by 1 centimeter. You can see that here I had written the value, that is after stretching this spring is going downward due to this block. So consider that at this position the block is now present. So now in the question it is saying that there is a particle of mass 120 which is dropped from block at a height of 45 centimeter. So consider that this is a particle whose mass is given, that is 120 gram, and height will be from block is, that is 45 centimeter. So now in the question it is saying that this particle is going to drop vertically. So after it will stick with this block. That means after dropping, the new condition will be, that is this particle is going to stick with this block, and both are going to with same velocity in downward direction. And so due to going downward, the spring is going, I can say that now spring is extending. So in this question it is asking that we have to find the maximum extension of spring after collision. So this is the question. I had explained every data by making a figure. So now let's start answering this question. So I can say that in the answer the mass of block is given, that is capital M is equal to 200 gram, or I can say that in kg it will be written as it is 0.20 kg, and mass of particle is given, that is small m is equal to 120 gram, or I can say that in kg it will be written as that is 0.12 kg. So and height of the particle from first block is given, that is h is equal to 45 centimeter, or I can say that 0.45 meter. So now according to question, as the block attains equilibrium, the spring is stretched by 1 centimeter. You can see that here the block is going downward due to weights and due to its own weight, and after it will take a equilibrium position. So due to taking equilibrium position, the spring is stretched by 1 centimeter. So I can say that the next step will be written as, that is own weight will be equal to spring force, means the block weight of block will be equal to spring force. So put the data. So it will be written as mg will be, that is m is mass of block, that will be 0.2 kg, multiplied by g is, that is gravity, and we know that g is value is, that is 10 meter per second square. So here I can say that 0.2 multiplied by 10 is equal to k multiplied by x. X is stretching, how much the spring is stretched by going downward due to for given block, this block. So in the question it is saying that 1 centimeter, so here I will write that is x is equal to 1 centimeter, or I can say that in the meter it will be written as it is 0.01. so here substitute the value of x, that is 0.01. now simplify it, then I will get the spring constant k, that is equal to 200 newton per meter. So now next step is I can say that you can the particle is dropping downward vertically, so the speed of the particle will be, that is, or I can say the velocity with the particle which is striking with block is given by the formula, that is u is equal to square root of 2gh, and I can say that it will be written as that is u is equal to square root of 2 multiplied by g will be, that is 10, multiplied by h will be, that is 0.45 meter. so I can say that put the value of h here, that is 0.45 meter. so simplify it, then I will get the value of u, that is initial speed of particle which is going to strike the block. so value is, that is 3 meter per second. so now next step is after the collision, consider that they are, as according to question, they are clinging to each other, and I will consider that they will go in same direction with same velocity, and that velocity is, that is v, capital V. so I can say that here I am writing that is after the collision, let the velocity of particle and the block will be, that is capital V. so now next step is apply a law of conservation of momentum. so it will be written as, that is initial momentum is equal to final momentum. so I can say that initial momentum will be, that is mu is equal to final momentum will be, that is m plus capital M multiplied by capital V. so you can see that in the figure, the after collision they are stick to each other and going downward with capital V, which I had assumed. so I can say that here final momentum will be written as, that is parenthesis of m plus capital M multiplied by V, and initial momentum will be, that is mu. now next step is substitute the data. so it will be written as, left side will be, that is mu, means mu will be written as, that is 0.12 multiplied by 3, u is which I had get in above step, that is u is equal to 3 meter per second. so that will be equal to small m plus capital M, that will be 0.12 plus 0. M is capital M is, that is 0.2 multiplied by capital V. so now simplify it, then I will get the capital V, that is equal to 9/8 meter per second. now in the question it is asking that we have to find the maximum extension of spring. so consider that maximum extension of spring is delta after collision will be, that is del. so my next step is, here I am using the conservation of energy, law of conservation of energy. So according to law of conservation of energy, it will be written as, next step will be, that is initial energy of system before collision will be equal to final energy of system. So I can say that the left side will be written as, that is initial energy of system before collision, that will be equal to half mu square plus half k x square is equal to, now final energy of system will be written as, that is half parenthesis of m plus capital M, small m plus capital M, multiplied by capital V square plus half k multiplied by parenthesis of x plus del square whole square. So you can see that here I will represent the del in the figure, that is after extending they will go furthermore delta down, del unit downward. So that means after collision the final position will be when after when they are clinging to each other and going with downward with final velocity, then consider that after del at del height they are taken a equilibrium position. So now I can say that the total spring will extend, that is x axis, that is 1 centimeter plus del after collision. So here I had written this spring energy after final stage, that is half k plus multiplied by x plus del whole square. So now next step is substitute the data, substitute all data. So it will be written as, that is left side will be, that is half m is given, that is 0.12, u square will be, that is 3 square, that will be 9, plus half k will be, which I had get in the above steps, that is k is 200 Newton per meter, and that is this k is equal to 200 Newton per meter. And I can say that x square will be written as, that is in the question given x is 1 centimeter, or I can say that in meter it will be written as, that is 0.01 meter. So x square, that will be 0.01 square, is equal to half small m parenthesis of small m plus capital M will be, that is 0.12 plus 0.2, v square will be, that will be I had get, that is v is equal to in the above step 9 by 9 over 8. So I can say that v square will be written as, that is 9 over 8 is whole square, that will give 81 over 64 plus half. Now k will be, that is 200 multiplied by x will be, that is 0.01 meter plus del whole square. Now simplify it, then I will get the value of del, that is equal to, after solving final value is, that is 0.016 meter, or I can say that in centimeter it will be written as, that is 6.1 centimeter. That means the maximum extension will be written as of spring will be written as, that is 6.1 centimeter. So I had solved the question completely. This is the answer of given question. Thank you.